Welcome back again to Advanced Functions, Trigonometric Functions chapter. In this lesson number 3, we are going to explore the different graphs of the primary trigonometric functions. So when we're drawing these primary trigonometric functions, we're going to use the unit radians instead of degrees. So first, we are going to complete the table for the sinusoidal sine graph. So as you can see above, these are the x-axis. These are the x values on the x-axis going from 0, pi, which is 180 degrees, to 2 pi, which is 360 degrees. And then this is at the bottom is the y value when x is 0. So what you could do is you could plug it into your calculator in radian form. Sine 0 is going to give you 0. Keep in mind, the important axis that I want you to remember is that pi over 6 is 30 degrees, pi over 3 is 60, pi over 2 is 90, and also keep in mind pi is 180, 3 pi over 2 is 270, and 2 pi is 360. So you will notice that pi over 4 is not here, which is 45 degrees, because the degree that I'm going at is by 30. Again, in your calculator, which is in radian mode, RAD, radian, you're going to press sine pi over 6, and it's going to give you 1 over 2. So pi over 6, 30, 60, 90, these numbers, you will notice that it will give you an exact answer. Why? Because it's part of a special triangles that we studied. 60, 30, 2, 1, square root 3. So as you can see, if it was pi the third, it's going to be opposite over hypotenuse. So it's going to be square root 3 over 2. So you can write it in decimal, or you could write it in an exact answer. And then we know pi over 2 is going to be 1. 2 pi over 3, when you punch it in your calculator, it's going to be square root 3 over 2. And then it's going to be 1 over 2. And for pi, sine to 180 degrees is 0. And then when you punch in sine 7 pi over 6, it's going to give you negative 1 over 2, negative 3 square root 3 over 2, and then 3 pi over 2 for sine is going to be negative 1. So same thing, you're going to repeat by plugging in all the angles, and at sine 2 pi is going to give you 0. Okay. Next, we are going to try inputting these x, the angles, which is in radian, for cosine. Same thing, for this one, you're going to plug in cosine 0, and it's going to give me 1. And then cosine pi over 6, and again, keep in mind that it has to be in radian. It's going to be square root 3 over 2, 1 over 2. And cosine 90 degree, pi over 2 is 0. So you're going to do repeat, continue, input the angles, negative square root 3 over 2. Pi of cosine is going to give you negative 1. Negative square root 3 over 2. Negative 1 over 2. 0. 1 over 2. Square root 3 over 2. And lastly, 1. And lastly, we are going to input tangent. So again, in radian, tangent to 0 is 1. And then tangent in radian, pi over 6, is going to give you 2 square root 3 over 3. Or you could put it as 1.2. Okay. And then it's going to give you 2. Now the next one, this is interesting. When you put tangent in your calculator, pi over 2, you will notice that you will see a math error. What that means, it's undefined. It does not exist. Okay, and then continue. Tangent, so I will explain why this does not exist. So keep in mind, at 90, so this is pi over 2. But at this point, if it's on the axis, we talked about unit circle in the previous class, and the x represents cosine and y represents sine. So if it's tangent, tangent is going to be sine over cosine. Therefore, it's going to be 1 over 0. As you can see, anything over 0 is going to be undefined, does not exist. So that's why you get math error on your calculator. Okay, let's keep going. So 2 pi over 3, you get negative 2. And then negative 2 square root 3 over 3, which actually it's negative 1.2, same thing. Tangent pi, negative 1. Negative 1.2, negative 2, and this is also interesting. When you do tangent 3 pi over 2, what do you notice? Again, you get does not exist. Okay, because of 1 over 0. Okay, so 3 pi over 2 is on this axis, on the y-axis. So this is a special case, which is 0 over negative 1. So again, it's going to be negative 1 over 0, which does not exist. And then 5 pi over 3 is 2, 1.2, and 1. So now the next part of the investigation is that I want you to use the previous table to sketch the trigonometric function. So the first one, which is part A, is the sine function, y is equal to sine x. So you can go back to your chart and you will notice that at 0, it's 0. And pi over 6, my output was 0.5, 1 over 2. So I'm going to label over here. And at pi over 3, it's going to be square root 3 over 2. So if you do square root 3 over 2, it's hard to figure out the numerical value. So divide it, and you're going to get about 0.87. So it will be around here. And at pi over 2, you get 1. And then at 2 pi over 3, you get 0.87 again. And then 0.5. And at pi, it's going to be 0. Same thing, I'm going to follow exactly what the chart says. At 7 pi over 6, our output was negative 0.5. So here, negative 0.5. And then negative 0.87. And then at negative 1, negative 0.7, negative 0.5, and at 2 pi for sine, it's going to give me 0. So I'm going to connect the dots. So try to draw a very smooth, curved line. So sinusoidal has to be a curved U-shaped graph. Okay. So this is the sine graph, okay, and it represents only one cycle from 0 to 2 pi. So later on in the chapter, we will be doing transformation from sine. So some of the key points I want you to remember for sine is when you draw the axis, so this is x and y, always divide it into 4 sections. 1, 2, 3, 4. So this 4 section represents 2 pi. So you're going to do 2 pi over 4 section, which will give you pi over 2. So each increment of the square represents pi over 2. So 2 pi, and then right at the half you have pi, and like I said, each increment represents pi over 2. And you will notice that the highest point over here is at 1, and the lowest point is at -1. So therefore, when you're drawing it, the sine, always start from right at the center, and you come back at the center. You always come back where you started with, and right in the middle is this, at 0, and you're going to make a U shape and a U shape like this. So in simple terms, sinusoidal function will look like this, up and down. Next, we are going to draw a cosine graph, cosine x. So look back to your chart, and at 0, my cosine is starting from 1. And then at pi over 6, we get square root 3 over 2, which is 0.87. And then at pi over 3, I get 0.5. And pi over 2, I have 0. And 2 pi over 3, we have negative 0.5. 5 pi over 6, you get negative 0.87. And at pi, you get -1. And cosine 7 pi over 6, our output was negative 8.7, 0.87. And 4 pi over 3 is 0.5, negative 0.5. And at 3 pi over 2, we get 0. Do you see the pattern here? It's very symmetrical. And 11 pi over 6 is 0.87. And at 2 pi, we're back at 1. Okay, so it looks like it's a U-shaped, but you have to be very careful. It's not a parabola. So cosine is a sinusoidal function, which is just a shift from sine graph. So you have to draw a curved shape. So this will be going in, okay? And then this will be going out. And then this will be curved in like that. Do you see that? So it's not a parabola. So for example, let me show you. This is not it. In simple term, again, you're going to divide it into 4 sections for cosine. 1, 2, 3, 4. So this is x, and this is y. So 2 pi, right in the middle we have pi, pi over 2, 3 pi over 2. Again, you will notice that the highest is at 1, and the lowest is at -1. So it starts at the highest, and it comes back at 2 pi at the highest. Right in the middle, you have the lowest. Okay, so then curved in and out, the U shape, and curved in again like this. Okay, so again, if I have to stress it, it's going to be curved in parabola, half a parabola, and then curved out like that. So do you see the difference between the parabola over here and this one? So this is the correct shape of a cosine. This is just x squared. A perfectly no curved in or out. Okay, so this is wrong. So please be mindful about curves. It's very important. It's 0. And then 0. So pi over 6 is going to be 0.6. Pi over 3 is going to be 1.7. So it's all the way up here. And then pi over 2, it's undefined. So what it means by undefined is that we have a vertical asymptote at pi over 2. So that's why you don't get any value for output for tangent at 90 degrees. And then 2 pi over 3, the output was negative 1.7, so it's like all the way here. Tangent 5 pi over 6, we got negative 0.6. And at pi, it was 0. 7 pi over 6 is 0.6. 4 pi over 3 was 1.7, so it's all the way up here. And then we have another undefined. So undefined again, it means that we have a vertical asymptote. And 5 pi over 3, negative 1.7. 11 pi over 6 is negative 0.6. And at 2 pi, we have 0. Okay, so let's connect the dots. So what this is, it's going to be going upward. But it's not going to touch the asymptote. It's going to go very, very close to it, very near the asymptote, but it will never touch it. So here, the curve it's important. So it looks very similar to a cubic function. So this one is going curved in like this. And this one is curved outward like this. And again, oops, I missed the point here. So for tangent, it's a little bit different. So you could definitely divide it into 4 sections again. So 2 pi, pi, pi over 2, and 3 pi over 2. So for tangent, we have an asymptote at pi over 2 and 3 pi over 2. And at pi, we have 0, 0, and 0. So similar to sine, but except that it's going, it looks like a cubic function that will never touch the asymptote like this. Okay, so that is the tangent function. Now, so we're going to explore some of the properties of sinusoidal and tangent. For amplitude, amplitude is the half of the vertical distance from the minimum to the maximum value. So if you are inclined to know the formula, amplitude is the maximum minus the minimum value divided by 2. Axis, the equation of axis, is the horizontal line that is right in the middle between the minimum and the maximum. So instead of subtracting, you will be adding it and dividing it by 2 because you're looking for right in the middle line, the center line. A cycle is a set of consecutive points on the graph that are repeated. So you will notice that sinusoidal function is a cyclic graph. And then period is a horizontal length of one cycle. So far, we've done the period to be 2 pi for sine and cosine. But for tangent, it was just pi. Okay, so let's fill in the table. For sine on the left, as you can see, it represents one cycle. So assuming that it's one cycle for domain is x can be any real number, but it's such that if it's one cycle, it's in between 0 and 2 pi. For range, y can be any real number, such that it seems like the lowest point is -1 and the highest point is 1. Now, is it odd or even? So what you can do is you can ask yourself, if it's even, it's symmetrical through the y-axis. And if it's odd, it's symmetrical through the origin. So that means this is going to go this way. So as you can see, it's not symmetrical through the y-axis. It's symmetrical through the origin. So what you can do, another mathematical way, algebraic way to figure it out, is you could plug in sine -x and see if you get sine x, which you don't. But if you were to get negative sine -x, you do get sine x. Okay, so it is odd function. Amplitude. So amplitude is maximum minus the minimum divided by 2. So in this case, 1 minus -1 divided by 2, which is 1. So you can think of it this way, from maximum to the equation of axis, this is amplitude, or the minimum to the equation of axis right in the middle, this is amplitude. Amplitude will always be positive. Equation of axis is maximum plus the minimum divided by 2, which is 0. So as you can see, I do have the equation of axis over here at y is equal to 0. So you do have to say y is 0. Period, in this case, the one cycle is up to 2 pi. Maximum point is at pi over 2, 1. And minimum point is at -3 pi, 3 pi over 2, comma, -1. And do I have any asymptote? None. There is no asymptote here. Let's do a cosine function. So domain, as you can see, it's same thing. X can be any real number. It's in between 0 and 2 pi, assuming it's one cycle. Range, y can be any real number. It looks like the lowest point is -1 and the highest point is 1. Is it odd or even? As you can see, it's symmetrical through the y-axis, so it is even function. Amplitude is, again, maximum minus the minimum divided by 2. It's going to be 1. So as you can just notice right away, that minimum point to the equation of axis, this is 1. Keep in mind, amplitude has to be positive. Equation of axis, as you can see, you're going to do maximum minus the minimum divided by 2. So y is equal to 0. It's right in the middle over here. Period is 2 pi. Okay, it ends at 2 pi. Maximum point. So it seems like we have two maximum point here. 0, 1. And 2 pi, 1. And for minimum point, we have pi, -1. And asymptote for cosine, it seems like we have none. And lastly, let's do the tangent. So for tangent, for domain, it seems like domain x can be any real number such that, assuming that we're going from one cycle from here, okay, so we're looking all the way up to 2 pi. So domain x can be any real number, but it looks like we do have restriction. Okay, it seems like the restriction it's at pi over 2 and 3 pi over 2. So you could say x cannot be pi over 2 and 3 pi over 2. Range, on the other hand, y can be any real number. So it's going to keep going up forever and ever, right? So therefore, there is no restriction for range. Is it odd or even? So take a look. Is it symmetrical through the y-axis? No, but it is definitely symmetrical through the origin. So we say it's odd. Amplitude. So to find the amplitude, you need to find the maximum and minimum and subtract it. But unfortunately, in this case, there's no maximum minimum. So for amplitude, there's none. An equation of axis, again, there's none because we cannot identify max or min. Period. So it looks like one cycle lasts, it repeats at pi. So this one is just pi for period, right? So for example, it starts here, and then another cycle starts over here. Okay, or another way to look at it, this one cycle is in between pi over 2 to 3 pi over 2. Okay, so when you subtract it, it's going to be 2 pi over 2, which is pi. Maximum points, there's none. Minimum point, there is none. And is there an asymptote? Yes, there is an asymptote. There is a vertical asymptote at x is equal to pi over 2 and x is equal to 3 pi over